All right, this video is going to talk about what we can do with division and how it's going to help us with polynomials. Polynomial division is really meant to help us find zeros or find factors or do kind of various things with polynomials. So just to remind us of how to do some division, we've got a couple examples up top here. They're great examples for synthetic division because notice both of our divisors are linear factors, or hopefully factors, but they're linear expressions here. So if we take our expressions, whatever makes the divisor 0 again is going to go up in the box for synthetic division. So again, I'm going to say x minus 2. Well, if I put a 2 in there, that would make that 0. I'm going to grab all my coefficients, 1, 2, -6, and -9. And then I'm going to go ahead and perform that synthetic division, dropping the first number down and then multiplying by the number in the box. So 2 times 1 would be 2. Add that up. Multiply again by the number in the box is 8. -6 plus 8 being 2. And multiply again by 2 is 4. Adding it up makes -9. Again, there's my remainder. So if I write out my problem, I'm going to drop the exponent. What used to be x to the third is now 1x squared here. What used to be squared is now only first power. So I've got plus 4x plus 2 and then plus a -5 divided by x minus 2. Again, we've got our problem, our answer there. And so let's move on to the one over here at the right. We've got a -4 that's going to go in the box because, again, that would make that divisor into 0. 1x to the fourth. Now you'll notice there's 0x cubed, so I'm going to go ahead and put a 0 in here because, again, there was no x cubed term up top. But then I've got -16x squared, 1x, and a 4 for the constant. I'm going to go ahead and move that first number down, multiply by -4, dropping down that -4 plus 0, multiply again by -4, adds to 0, multiply again by -4, 1 plus 0 is 1, and multiply one more time by that -4 up in the box, and that makes for a 0 remainder. So again, dropping our exponents by 1, this becomes an x to the third, minus 4x squared plus 0x plus 1, and we get our final answer there because our remainder of 0 as well. We don't need to write that in. Now, one kind of unique fact, that remainder also gives us kind of a hint of something. Again, if this is f of x up top here, right, and we just divided by, right, this 2 in the box, what we just figured out was that f of 2 is actually equal to -5. It's kind of a unique fact. So we call the remainder theorem. We'll talk about that a little more on the next page. The remainder theorem. In fact, let's go ahead and go there. If f of x is divided by x minus k, a factor, or what a possible factor would be, then the remainder, right, that we get is f of k. So that's basically what we just said. F of 2, right, plugging 2 into that numerator, right, into the dividend or the numerator would give us -5. What it also means is, in the problem over here, right, again, if f of x was on the top, what we just figured out is that f of -4 would equal 0 this time, right? Which just means that we divided in there evenly, and not only is f of -4 equal to 0, but x plus 4 is a perfect factor of, right? A perfect factor of that numerator. And that's a really unique and helpful fact. What does it mean when the remainder comes out to perfectly 0? Well, it means that x minus k goes in there evenly, and according to what we call the factor theorem, f of x has a factor, right? That polynomial, that numerator would have a factor of x minus k. Because, again, that remainder came out to 0, right? F of k was 0. Now, we can take advantage of that fact. That's a very helpful thing. Is x plus 3 a factor of x cubed minus 19x minus 30? Well, one thing we could check and see is -3, right? If x were equal to -3, is that a 0 of my function? I could just plug -3 into my polynomial there and double check and see if that's a 0 of my function. But now they also had mentioned, okay, let's check that by synthetic division. It's not a bad way to go because synthetic division is so fast. We can say -3 in the box, 1x cubed, 0x squared, don't forget, you're missing that x squared term, minus 19 minus 30. And we can drop that 1, multiply by -3, -3, multiply again by -3, adds to -10, multiply by -3, we get that 0. And because it comes out perfectly to 0, we can say that yes, x plus 3 is a factor. We can even be specific of x cubed minus 19x minus 30. What it also does is allows us follow-up question down in the bottom. What if we wanted to factor x cubed minus 19x minus 30? Well, I know one of my factors right now is x plus 3. And the other two factors, because again, it was x cubed at the beginning, right? So I expect 3 factors. But that's going to come from this part down here, this sort of leftover numbers after the synthetic division. So now this is x squared, right, minus 3x minus 10. And if we think about it, what would multiply to -10 and add to -3? Well, I would say -5 and +2 sound pretty good. So I can just factor the good old-fashioned way there and take the rest of that quadratic apart, and we just factored that cubic problem. So again, synthetic division provides us a way to sort of factor these problems out. Right? So again, things that we should know, going into the next video, things that we should know walking away from this one. Again, a remainder of 0 after dividing by k means that we have a factor of x minus k. And again, f of k then, plugging k into the function, would need to come out to 0, right? It would be a 0 of the function. All 3 of those things go together very nicely. Again, if you want to see an example of where we can use this, maybe finding zeros of a function, watch the next video. Otherwise, have a great day.